another video. In this video, we are going to solve a sum based on minimization problem under the chapter assignment model under Hungarian method under the subject operation research. Now, this is our fifth problem sum under our video series based on assignment model. This is going to be one of the most advanced sum under minimization problem sum. So see that everyone view this the method of solving very carefully. So let us see how to solve a very advanced sum based on minimization problem.
Okay, now let us see how to solve this particular question. This is the fifth question in our video series, okay, based on assignment model. Find the total minimum time required. So again, it is a sum which is based on minimization. So find the total minimum time required to complete 5 jobs by 5 men from the following time. Okay, so now we have been given various jobs and we have been given men. So first thing is always check whether the sum is a balanced sum. We have 5 jobs and we have A, B, C, D, E, the 5 men. So it is a balanced problem sum. So we can directly start this start the sum. Step number 1, in order to solve sum based on minimization, your first step will always be we need to find the values of row minimization. Now, in order to find the values of row minimization, first step will always be we'll have to create a similar table having jobs and men but with the new values. Okay, so with the help of a scale, what we'll do is we will create a similar kind of a structure whereby we'll have the values of jobs and the values of men. Okay, so now for the jobs we have job 1, 2, 3, 4 and 5, and men may we have A, B, C, D and E. Now in order to get the values of row minimization, the rule is we'll have to pick up each row. From each row we need to find the lowest value, and that lowest value will be subtracted from each and every other values in that subsequent row. So in the first row the lowest value is 2, so all the values minus 2. So 3 minus 2 is 1, 10 minus 2 is 8, 3 minus 2 is 1, 8 minus 2 is 6 and 2 minus 2 is 0. Similarly in row B the lowest value is again 2, so 7 minus 2 is 5, 9 minus 2 is 7, 8 minus 2 is 6, 7 minus 2 is 5 and 2 minus 2 is 0. In third again the lowest value is 2, so it will be 3, 5, 4, 2 and 0. In the row D the lowest value is again 2, so 5 minus 2 is 3, 1, 8 minus 2 is 6, 4 minus 2 2 and again 0. And in our last row again the lowest value is 0, so it will be 6 minus 2, that is 4, 4 minus 2 is 2, 10 minus 2 is 8, 6 minus 2 is 4 and 2 minus 2 is 0. Step number 1, we found the row minimization. Second step, we need to find the column minimization. Now again, in order to find column minimization, we'll have to create the structure which has all the rows and columns. Okay, so again we'll have the number of jobs and we'll have another column for a number of men. So in jobs we have 1, 2, 3, 4 and 5. Men may we have A, B, C, D and E. Now column wise, from the row minimization, from each column get the lowest value. That lowest value will get subtracted from all other values in the corresponding column. Now in the first column the lowest value is 1, so 1 minus all other values, so 1 minus 1 is 0, 5 minus 1 is 4, 3 minus 1 is 2, again 2, 4 minus 1 is 3. Okay, in the second the lowest value is again 1, so 8 minus 1 will be 7, then 7 minus 1 is 6, 5 minus 1 is 4, 1 minus 1 is 0, and 2 minus 1 is 1. In the third the lowest value is 1, so 1 minus 1 0, 5 minus 1, 6 minus 1 is 5, 4 minus 1 is 3, 6 minus 1 is 5, and 8 minus 1 is 7. In the fourth column the lowest value is 2, so it will be 6 minus 2 4, 5 minus 2 3, 2 minus 2 0, 0, 4 minus 2 is again 2, and last is 0, so we note down those values as it is. So here we are done with row minimization and column minimization. Now our next step is row wise. We'll have to first find all the zeros and assign them a square. If the rows we are not able to assign anyone though, then we'll have to go and check in column wise. Okay, first always those rows which has only one zero will be assigned. Thereafter columns in which there are only one zero, that will be assigned, and thereafter whatever is remaining we can assign those zeros. So chalo, let us see one by one. In the first row A, there is 1 2 3 zeros are there, so we can't assign because we have to first check only those rows and column which has only one zero at the start. So we'll skip as of now. We jump to the next one. In the second row, okay, 4 6, there you can see there's only one zero, so we will assign that particular zero. Now the rule is the moment we assign the zero, all other corresponding values in the opposite sector, that is if we are taking rows, all the columns may all the zero gets crossed out. Okay, now in the third row again I can see there's only one zero remaining, so we assign the value. The moment we assign, all other values get crossed out in the subsequent column. In the fourth there is again one zero, we mark that. Fifth may apparently there is none. So now all the rows are done, we go column wise. In the first column there's 1 0, we mark it. The moment I mark the column, all other values in the rows get crossed out. Second may already there is, third there is none, fourth may there is already marked, and fifth may also there is already marked. Okay, now once we are done with that, okay, now what the next step is, now we'll have to first check the number of assigned values and the matrix size. So here the assigned values 1 2 3 4, there's only 4 assigned values, but the matrix size is, it's a 5 by 5 table, so the matrix size is 5. Therefore the solution is not optimal. The solution is not optimal. So okay, so if the solution is not optimal, we'll have to create a next table that will be a modified matrix. Okay, now again modified matrix will have the similar columns, okay, where we'll have the jobs and the men, so we will mark it out. So we'll just make the structure and keep it first. Okay, in job we have 5 jobs, so 1 2 3 4 and 5. In men we have 5 men, so we have A B C D and E. Now coming back to the previous column minimization table, now since the sum is not optimal, we'll have to start crossing or making lines and crossing out those values which has all the zeros and stuff. So the rule is the row which has a zero but which wasn't assigned and has been crossed out, that particular row needs to be first selected. So if you look carefully, the first row has assigned, second has, third, fourth, fifth doesn't have any assigned zero, but there is a zero available that. So from that particular row, corresponding column will have to be first crossed out. So we'll have to draw a line passing through that. So that's number 1, the very first line. Now after that, okay, we need to check all those rows which has multiple number of zeros. So now if you can look carefully, the row D has multiple 0 because there are 2 1 and 2, so we cross that particular row. After that, check if there are any other. Now your the row C and row 1 has 1 1 0 each, or the sorry, row A also has 2, so we will cross out that also. And whatever is remaining is C, so we'll just cross that. That's the last thing which was available. So now if you look carefully, we have 4 lines, okay, and the matrix size is 5, okay, so there was surely you know, not an optimal solution. So now in order to find the values of the new modified matrix, the rule is from the unmarked value select the lowest value. So from the unmarked, the lowest is 1. Now whatever is the lowest value, subtract that value from all other unmarked values. So 4 minus 1 will be 3, 6 minus 1 is 5, 5 minus 1 is 4, 3 minus 1 is 2. Next unmarked is in the last row. 3 minus 1 is 2, 1 minus 1 is 0, 7 minus 1 is 6, 2 minus 1 is 1. Second rule, the second step is wherever the point lines have been intersected, you can see this intersection line, intersected. All those points will get added by the least value that we have selected. The least one was 1, so that 1 gets added to all the intersected point where the lines have been intersected. So here 0 plus 1 will be 1. Again in third row it was 0 plus 1, so that will become 1. In fourth row again it was intersected, so 0 plus 1 is 1. Okay, and in all other cases, whichever has been marked out, the value will remain as it is, so we just note it down. So we have 0704, again a 0 here. In third row we had 2430. In the fifth in the fourth row it's 2050, and the last one there was 10 available. Okay, chalo. So we have a modified matrix ready. Again we'll have to do the same marking of assignment or assigning all the zeros. We start from the row wise. The row which has only 1 0, we'll assign that particular value first, and thereafter we will go towards the next. Once all the rows are done, we go with the column in the similar manner. In the first row there are 2 zeros, can't mark either of them, so we go ahead and check for all those rows which has only 1 0. Now the row B has only 1 0, so we assign that. Corresponding all other values in the columns will get nullified or will get crossed out. Again third row only has 1 0, all other get crossed out. Fourth has only 1, so all other get crossed out. Fifth doesn't have any because the values have been crossed out, so we go column wise. The first column has only the first 0, we mark, all other corresponding values get crossed out. Second already done, third done, fourth, fifth, so there are no other zeros pending. Okay, so our now next step is again we check the assigned values. So our assigned values 1 2 3 4, again our assigned value is only 4, and our matrix size is 5. Therefore still the solution is not optimal, so we'll write therefore the solution is not optimal. This is the first time where even after making the modified matrix we were not able to get the optimal solution. So in such a situation, when after getting solving getting the modified matrix, still if you don't get an optimal solution, the step will repeat. We'll have to create another modified matrix. Okay, we'll have to keep doing this till we don't get the optimal solution. So again we'll have to make another modified matrix. Again similar structure will be available, so we'll make the structure where we will have again the various number of jobs and the number of men. Okay, so in jobs we have again 1 2 3 4 and 5. In men we have A, B, C, D and E. Again the same, we'll have to start crossing those lines because we were not able to get the final optimal value. So again the rule is same. The row which does not have any assigned 0, from that we'll have to start crossing those lines. Okay, So chalo, let us do that. Now first, second, third, fourth have, the fifth didn't have any zero which were assigned. So from there we'll have to start. So let's say there are now two zeros. This is the first, this is the second. So from there we'll have to start crossing all the columns. So let's say from here we crossed out the first column because it had two, and from here another column. Okay. Now the next rule is wherever you can see other zeros, we'll have to cross those. Now I can see there are multiple zeros here, so we will first cross out those, that particular row. Okay, so we have now 1, 2, 3. Now where are the zero? You can see here there are two zeros available, so we'll cross out that particular column. So we have to create those many, cross those so many lines as to cover up all the zero. Try making the least number of lines which are possible. Okay, chalo. Now once we are done with the line, see all the zeros have been covered up. So now the rule is all the unmarked value, from all the unmarked, okay, we'll have to select the lowest value, the least value, and from that particular least value we'll have to subtract all other unmarked values. So the least among the unmarked is 2, so we'll have to minus all the unmarked with the value 2. So 3 minus 2 is 1, 2 minus 2, 2 minus 2, 2 minus 2, all the three values will be 0. In the third column, 4 minus 2 is 2. 3 minus 2 is 1, 5 minus 2 is 3, and 6 minus 2 is 4. Step 2, whatever was the lowest value, that value gets added to all the intersecting point of the lines. So here the point has been intersected, so 7 plus 2 becomes 9. Again here the point has been intersected, so 4 plus 2 becomes 6. Here again it has been intersected, so 1 plus 2 is 3. All other values will remain as it is, so it will be 0, 0, we have 5, 4, 0, 0. Here we had 2, 0, 0, 1, and lastly it will be 1, 1, 1, 0. Okay, so here we have again created the modified matrix. Again we'll do the assigning of the zeros. First row, again two zeros, cannot do anything to that. My bad, this is a 0, so I have missed out a 0 here, so this is 0. Okay, first row does have two zeros, cannot do anything. We go ahead. The second row has 1 0, we assign that particular 0. The moment we assign, all other corresponding values in that column gets crossed out. The second row, I mean the third row has two zeros, can't do anything. The fourth row has 3 zeros, again can't do anything to that. The fifth row again has, two zeros, can't do anything. So in the row we were only able to do one of the rows. So now we start the column wise. Okay, in the column wise, the first column has 4 zeros, again can't do anything. Second has 2, can't do anything. The third has only 1, so we can mark that, assign that. The moment we assign that, all other corresponding values gets nullified. The fourth, again the fourth row, there are 2, so we can't do anything towards that also. Okay, now we come to a position where in each row, now in this row there are 2 zeros, in this there are 3, in this there are 2. So now there are multiple solution or alternate solution which are available. So now what we'll do here is we will have to mark out any one. Now let's say in C, in the row C, the very first row which has the multiple, in row C there are 2 zeros, so any one of them can be assigned and the other one can be crossed out. So let's say we'll assign the very first value itself. So let's say if I assign this, all other corresponding columns and row will get nullified. Okay, again in the next row there are 2, so we can't. In the third there's only 1 available, so we mark out that. The one above that will get crossed out and the whatever remains is the last one. So now after doing that, if we check, now we'll have to check the assigned value. So now we get here is the assigned value 1, 2, 3, 4, 5. Assigned value is 5, and our matrix size is also equals to 5. Therefore the solution, now finally it is done, so therefore the solution is optimal. So we were able to get the optimal solution. So our final answer now, therefore the optimal assignment is, okay, now the optimal assignment. So for job, for men A, the job which was given was 3. The value for that was, so A3, the value is 3. For job, for men B, the job given was 5. The B5 is 2. For men C, the job which was given was 1. So C1 is 5. For men D, the job which was given was 4. So D4 is 4. And last, the men E was given job number 2. Job number 2 for E2 was 4. The total of which is 3, 4, 5, 10, 14 and 18. Okay, and now these are all in hours. Therefore my final answer, therefore the total minimum hours equals to 18 hours. That's my final answer. Okay, so with this we were able to solve one of the most advanced sum under minimization problem under the subject operations research. The chapter name was assignment model. Okay, this was the first sum in which we were not able to get the optimal solution in the column as well as in the first modified matrix. So we had to make another modified matrix, do the same step, okay, repeat the same step, but we'll have to do it in order to get the optimal solution. Again we were able to complete, this is our question number 5 under our video series on optimal, the assignment model. Okay, I hope you all have viewed all the 4 videos, the 4 sums that we had solved in the previous 4 videos. If not, see that you all do view them, so that this all the concept becomes very easily and clear in your mind. Okay, I hope everyone have understood this, one of this advanced sums under assignment minimization problem. Okay, chalo, so with that we will be ending this video here. Thank you.